Hello. In the previous video, we learned how to calculate the median when you have raw data. It was easy to understand because when you have raw data, what you have to do is order them and find the middle value. So it's visually the middle value. But now in this video, we learn how to calculate the median when you get a probability distribution table. Of course, when you get a frequency distribution table, then you have to transform the frequency into probability first and then continue from there. So I will assume that the probabilities are available. And just consider a simple example data set. And of course, it's the fake data, but just put a name like, say, interested in the number of pets in a household. So number of pets can be 0, 1, 2, 3, 4, and the probability distribution is given as follows, like 28%, 21%, 19%, 17%, and 15%. So if the probabilities were equal, if the probabilities of these five outcomes were equal, then the middle will be easily 2. So if the five outcomes are equally likely, then the middle value is easy to understand. But now the difference is it's more likely to be 0 than 4. So smaller than 2, the left side is heavier than the other side. Then you have to balance the the weight, the probability, and find the middle given these numbers. So using the probability, we mathematically the median has to satisfy these two conditions. The first probability implies that the probability that x is equal to or smaller than the median must be at least 50%. At the same time, the other side, probability that x is greater than or equal to the median must be at least 50% too. So on the smaller side and on the larger side, both sides have to have at least 50%. You may be you may think it's impossible because how can the sum of the probabilities, two probabilities can be greater than 100%. If it's greater than 50%, then automatically the other side should be smaller than 50%. But that's not the case because overlap is equality sign. So x equals to 1 point is included in both probabilities. So due to the double count, the sum, even if one side is greater than 50%, the other side can be greater than 50% at the same time due to the overlap. So there is an overlap, so the sum can be greater than 100%. Anyhow, this is how we define median using probability. This is the mathematical interpretation of cutting, dividing half and half. To do that, it's a little bit complicated. We are going to define a new probability, totally new probability, which is the cumulative probability. I will simply shorten it as CP, cumulative probability, and it's intuitive. This is a probability smaller than or equal to a value. You may consider this guy, probability that x is smaller than or equal to the median. So now generalize it. It's cumulative probability. Probability is accumulated up to a value. So from the probability distribution table, the cumulative probability is calculated this way. As the value increases from 0 to 1 to 2, 3, 4, the cumulative probability must increase too, because as you accumulate more. So when you choose 0, the probability smaller than or equal to 0 is only 28% because there is only one outcome satisfying this condition. But when you have 1, then the cumulative probability includes two outcomes smaller than or equal to 1 includes 0 or 1. So these two probabilities are added. That's the cumulative probability. Probabilities are accumulated, and if you choose 2, you accumulate one more probability. So smaller than or equal to 2 includes three outcomes. So the sum of three probabilities makes the cumulative probability, which is 68%. And you can keep going. Excuse me. 3, when you choose 3, probability smaller than or equal to 3 is 85%. And 4, because 4 is the maximum in this data, so all the observations are smaller than or equal to 4, so it's 100%. Mathematically, you may write it this way. Probability x smaller than or equal to 0 equals to 28%. Probability x smaller than or equal to 1 equals to 49%. Dot, dot, dot. Cumulative probability also plays a very important role later, so you better, I strongly encourage you to keep it in your memory for later use. And the later use will be much more important than what I'm doing here. But basically, it's anyhow. So okay, how to explain now? So we need cumulative probability, and once you get the cumulative probabilities, say remember we had these conditions. So to satisfy the first condition, probability that x is equal to or smaller than the median must be at least 50%. So that means the cumulative probability at the median is at least 50%. So the median, we are looking for the median, and it should have cumulative probability greater than or equal to 50%. So there are three candidates. The first two guys do not satisfy the first condition. And then among these three candidates, you have to choose the smallest value. Then automatically the second condition is satisfied. So choose the smallest value among the values that have cumulative probability at least 50%, right? So if you do the math, calculate probability smaller than 2 is these three guys, so which is 68%. But if you calculate probability of 2 or 3 or 4, then you will get 51%. You may calculate that probability from here. Add these three numbers, then you will get 51%. So both conditions are satisfied. So that's the median. By the way, one thing important here is you may be tempted to choose one because its cumulative probability is closer to 50%. You may think the median is the 50%. That is right. Median is related to 50%, but you should not it's not the value closest to 50%. It has to satisfy at least 50%. That's the main difference. Even if 68 is farther from 50 than 49, still you have to take this. This is this satisfies the mathematical condition. That's important. And it's your turn to do an exercise. Now think about different data about household size. How many people in your how many family members in your household? 1, 2, 3, 4, 5. Actually, these numbers are real numbers, um, like rounded numbers, but quite similar to the truth. So anyhow, try to find the median household size given this probability distribution. You need to calculate the cumulative probability, and then remember, we need to find the smallest uh, greater than 50%. Okay, I'm going to continue in the next video. Try this, do the math, and see you in the next video.